Good morning, this is Dr. Sola from AWPS Renewable Energy, and today we're going to talk about a common problem that people who live off-grid experience, and that is batteries that have different voltages. You have voltage readings that you have a battery that will read 6 volts and another that will read 4 or 3 volts, and then when you put a load, the whole system collapses. So first things first, I always advise anyone that's going to do anything off-grid to have a generator. For those days when you don't have enough sun resources, and which is what we're experiencing in Lagos right now, you can turn the generator on to help you charge the batteries. So what am I doing? I'm doing a couple of things. I don't have a generator, so I've reduced my battery bank. I only have 2 kilowatts in panels. I'm using a 60 amp MPPT charge controller, this one, and I've reduced my battery bank to 250 amp hours. So this side, I'm going to equalize using my panels. This side, I'm going to charge using a battery charger. And I'm charging them in 12 volt increments. So I'm charging this 2, then tomorrow I'll charge this 2. And then what I'll do is I'll equalize this for 2 days and then move everything to this side and then equalize this for 2 days, and that should bring my batteries back. I don't have a multimeter. My crew are out on the job and they have all 3 multimeters with them. But I can tell you I've experienced this before where I had one of the batteries that was at 4 volts while the others were close to 6 volts. And what a system always does is it will read the battery with lowest voltage. So currently I'm running equalize. We're producing 627 watts, 22 amps, and my charger is pulling 10 amps out of my system. So as you can see, it's going to take a while before we get equalized. Actually, what I'll do now is I'll turn the charger off. It's an old Schumacher 10 amp charger. I'm running it through a step down because I purchased this in the US, and in the US we run 110 volts. So I'm running it through a step down, and as you can imagine, this is putting 10 amps in, so it's definitely pulling quite a bit. I'm going to turn them off right now. The voltage of my batteries, as you see, is 2732. When I turn it off, let's see what that jumps to. Didn't make much of a difference. See, it went up to 2740, so it didn't make enough of a difference to justify putting it off. So maybe I should leave it on, or maybe our production dropped. Well, we're still pushing 23 amps. So the consumption from this wasn't making much of a difference as to what I was putting into my batteries. So I'll report back to you in about 2 days to see if we got the desired results. A lot of people have been experiencing this. I read posts on Ireland where people go, oh, my batteries have already gone bad, I have to replace them. No, you don't. You overcharge them, and that's how you bring them back. So we'll do a video next time that shows actual voltages from the batteries, and then we'll show you what the results are after we've done the correction. And this should take us about 4 days, 2 days for each battery bank. And on the 5th day, we'll report back to you to tell you if we're maintaining constant voltage on our battery bank. Again, this is Dr. Sola, Christopher Wasanya with AWPS Renewable Energy, signing off from